In this video, I want to talk about Newton's second law. And Newton's second law is really just an equation. And that equation is that force equals mass times acceleration. And the point of this equation is that forces cause accelerations. The larger the force, the larger the acceleration. So again, if we have this object, we know if we apply a net force on this object, then we should expect it to accelerate. And that's what this equation tells us. So now if we know the magnitude of the force and we know the mass, we can determine the acceleration. For example, let's say we have this 10 kilogram mass, and let's say we apply a 10 Newton force. If we have this mass and we apply 10 Newton force, what's the acceleration that this object should go through? Well, again, we could just use Newton's second law. Force equals mass times acceleration. We know the force is 10 newtons. We know the mass is 10 kilograms. So now we can solve the acceleration. And we can see, just with a little algebra, we can see the acceleration must be 1 meters per second squared. So if we have a 10 kilogram mass and we apply a net force of 10 newtons, then we would have an acceleration. How much of an acceleration? An acceleration of 1 meters per second squared. So that makes sense. If we apply force, we get an acceleration. But what if we have that same object? But what if we apply a stronger force? Maybe this time we apply 100 Newton force. What should we expect? Well, again, we should have an acceleration, but this time we should have a larger acceleration because we applied a stronger force. If we apply a stronger force, we should expect a larger acceleration, a stronger acceleration. And we see that mathematically. If we increase the force, mathematically we should increase the acceleration. They're proportional. So what would be the acceleration in this situation? Well, again, force equals mass times acceleration. The force is 100 newtons. The mass hasn't changed. That's still 10 kilograms. So now solving for acceleration, we would get an acceleration of 10 meters per second squared. So that makes sense. We applied a larger force, so we got a larger acceleration. This block should accelerate faster. And that's the essence of this Newton's second law. And knowing this Newton's second law, there are a couple conclusions we can come to. For example, if you have an object, let's say we have this object. If you know this object's mass and you know the acceleration it's experiencing, you can determine what force it must be feeling. If we have this object and we know its mass and we know its acceleration, we could infer what force it must be feeling. And we know that from Newton's second law. Also, for example, if we had the same, if we know a force on an object and we know the mass of the object, if you know, so we know the mass of the object and we know the force it's feeling, we can determine what acceleration it must be feeling. And again, we prove that with these two examples. And also, if you know the force an object is feeling and you happen to know the acceleration it's feeling, then you can determine what the mass of the object must be. So these are all implications of Newton's second law. And we can see mathematically how these variables are related. For example, focusing on this equation, let's say we have a 10 Newton force. So we have a constant force. If we apply that 10 Newton force on a certain mass, we would get a certain acceleration. However, if we apply that same 10 Newton force on a larger mass, we would have a smaller acceleration, and we can see that mathematically. If we increase this denominator, we would increase this value. So we can see that mathematically, and that makes sense. If we apply this 10 Newton force to a book, a small book, we should have a certain acceleration. However, if we apply that same 10 Newton force to an elephant, we would get a smaller acceleration. It has a larger mass, so we should have a smaller acceleration. We have a larger mass, smaller acceleration. So that's the essence of Newton's second law.